Brought to you by ConnectJS, Atlanta's premier JavaScript conference. Sponsored in part by FeatherDirect. Need a mobile app? Contact us for your custom mobile solution.
So we're going to be talking about securing AngularJS applications. It actually could have been more generically titled securing heavily JavaScript-based client-side applications, but that was too long-winded and this sounded better. So the example we're going to be using is an Angular application. Actually, the same rules apply to mobile applications. Anything where you've got a heavy JavaScript or client-side set of code and the interactions between it and the server. So let's jump in. Brief bit of information about me. I do a lot of security talks, or have over the years, and I've come to the conclusion after hearing a lot of people talk that everybody has a bias or a point of view. You look at the world in a certain way, and the way you look at the world can give you blind spots. So I think it's always fair for security talk to kind of say, here's what my point of view on the world is. Go find other people with other points of view, and hopefully when you get all that together and triangulate different points of view, you'll see reality. So I'm the founder of Saltworks Security. Married, 2 kids, a lizard. Love dual sport motorcycling. I'm starting an Atlanta chapter of a group called Hackformers, which is a group of Christians in the security community. So if you're interested in learning more about security, and there's some really good speakers that have come to that. Michael Howard from Microsoft, Marianne Mazopeth, who's the Chief Security Officer of Oracle, has come to that. So some really good, interesting folks. Background, I'm an industrial engineer. I did an industrial engineering degree with an emphasis in systems, which when I was in college, that was you were either a computer science guy or a double E major, or you went into industrial engineering to code. So that was the route I took. Been coding since 1984. I got into this professionally because I had 3 options to pay for college. I could give plasma, which you go flat pretty soon if you do that too much. I could flip burgers, and I'm not good at that, but I didn't know how to code. So I started coding for a professor, and have been coding ever since as a developer since in the mid-'80s. Been coding in applications, specifically on the web, since about '96. Did one of the early online auctioning systems way back years ago. Have been dealing with dynamic HTML since about 2000. Back then, there was this really primitive, incredibly unelegant way to do JavaScript in the browser. It was very browser specific, but we used it for some systems we developed. So been dealing with kind of this whole concept of how do you deal with dynamic content in browsers and interacting with servers. Actually got into security through that event. Some guys that had just founded this little company called SPI Dynamics here in Atlanta were hired to do a penetration test. So if you've ever been the happy recipient of a penetration test, that's when somebody hires a professional hacker to break into your system and just tear it apart. So they did that to the system I'd architected. They destroyed it, just absolutely killed it. It was horrible. So in the process of fixing those issues, I got recruited by the company to come write a program called WebInspect. So I was the first developer of the tool that basically automates hacking called WebInspect back in 2000, and kind of been in this industry ever since. So kind of a bit of my background, so sort of developer security geek for about the last 14 years, sort of in parallel and working with lots of companies. So quick survey, and I think this is important just in the context of what we're going to be talking about. Does anybody here only write client-side code? You do not touch the server. If you only write client-side code, raise your hand. Okay, cool, a few people, good. If you only write server-side code, raise your hand. I'm going to assume that everybody else writes both. So this applies to you, so good. There's a couple of people who only do client-side code. If you only do client-side code, that's cool. If your security people or your server-side people aren't helping you, then you should talk to them quickly. So good, this is going to talk to both people. So it was interesting when I proposed this talk, I sent in a proposal to give a talk on Angular security, and one of the guys from the conference said, well, Angular is a client-side technology. There is no security in the client, which I agree with, by the way. So security and Angular really don't apply. That's not necessarily true. Anytime you're designing a system, so if you're coding in it, for example, an application in Angular, you still have to do things and interact with the server in a secure way. And as most people in here write server code and browser code, it absolutely falls in your wheelhouse. So the way that you implement security absolutely applies to how you develop an Angular application, or more generically, many types of applications. So Some of the things we're going to talk about and some of the big mistakes are things like authentication, session management, the nature of transactions. And this came out, I'll tell you how this talk developed in just a minute. When I was doing the talk, I'm a fairly new Angular developer. Been doing security a long time, but relatively new to Angular. So I called a bunch of pen testers that I've been friends with for years. Probably together, they've probably pen tested well over 1,000 mobile applications and probably in the tens of thousands of web applications, the population of people from the researchers, and basically said, what do you see on a day-to-day basis? And what we're going to be talking about today were the things they see over and over and over and over and over again, okay? So, which made me happy because I figured I wasn't totally off the rails. So let's jump in. So application security vulnerabilities generically, there's a lot of different ways to think of application security vulnerabilities. Generally speaking, if you're talking to pen testers, they focus kind of in 8 major categories. The really nerdy term is the 8 pernicious kingdoms of security vulnerabilities. It's kind of an academic way of saying what are the categories, the styles of coding that you're going to get eaten alive on. And there's a guy that several people came up with this years ago. We're going to come back to this, so I'm not going to dig into it too heavily right now because we're going to dig into it a lot deeper later in the talk. But I did just kind of want to give you some context, and it's basically the styles of coding. So we're going to go through some of these, and then we'll revisit it at the end. Couple of simple rules for security, and this is just after seeing a lot of people make a lot of really, really, really bad mistakes. I was the original developer of a tool called WebInspect. It's probably scanned 50, 100,000 websites now. There's a couple thousand copies of it out there that people use. This is what I've seen over and over and over and over and over again. So basic rules of life for me, keep security as simple as possible. And what I mean by that is keep it as simple as possible for the developer of the application, the end user application, even if you're the developer of the end user application. Make your security simple, make it very clear. Secure, things should be secure by default. So if I know nothing and I start using your RESTful web services, for example, if I just barely get my application to work and say hello world, it should be secure. So secure by default is a big deal. Don't make people do weird stuff to secure your application, or they won't. Make it usable. If your security that you implement, the methodologies you implement aren't easy, they'll get circumvented. They just will. I can give you many examples of that. So the secure way to do something should be reasonably easy, and we'll show some examples as we go along. It should be flexible. This is one to save you a lot of pain. It should be auditable. Auditable means, can you explain how you did something to a non-programmer? An auditor comes in and says, how did you do A, B, and C? If you start saying the word inheritance, overrides, injections, any of those terms, probably going to fail. Not that those are bad, it's just that the auditor won't understand you. And the default in auditing world is fail. If you can't explain it clearly, fail, okay? So you want to pass. You want to get past your auditors. Nobody likes being audited. So make your security very clear, very simple, very easy to understand. Also, test it. Always, 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 always test your security. However you implement security, try to break it. Try to circumvent it. Try to get around it. People make a living doing this. Next rule, limit the number of people that have to make security decisions. Just basic truths of security. Security is very, very expensive in time, in investment, in labor. It's difficult. If it's not hard, you're doing it wrong. What I mean by that is if you're making security decisions, for example, how to do encryption, and you think it's easy, either you have a PhD in encryption or you're wrong. That's just simple rules. And also from an auditing perspective, if you've got lots of people making hard decisions like how to do encryption, the challenge is when your company gets audited, they have to go find a PhD in encryption to see if you did it right or not. Whereas if you use some standard libraries, they go, oh, great, you use that standard library. Check, move on. Okay, so make your life easy. Limit the number of decisions, even if it's you. So I hate making security decisions. Been doing this for 14 years, hate it. I'll show you one example of one that I did make, and I'll explain why I did it the way I did it. Avoid security decisions. So try to use out-of-the-box things, native session management, native authentication, native encryption to your environments. Don't roll your own code. If you're rolling lots of your own security code, red flags should go off on your head really, really, really badly. Keep in mind, you may be smarter than every person on the planet. You are not smarter than all of the people in teams that are very patient and want to hack you. Lots of people make decisions and they think they're smart. I've literally been sitting with a group of developers and they were explaining to me how they defended against cross-site scripting in their application as the tool that I wrote cross-site scripted their application, and it showed them on the screen when it was happening. So this happens all the time. So, again, use standards, don't try to roll your own code. So let's jump in. So how do we get here? I like old stuff, by the way, so you'll see just random old things in my presentation. So the way that I got into doing this talk is I also develop a website for some people. We decided we wanted to redo it in Angular just because it's a really nice framework, aesthetically, graphically, it functions really well. I don't know how to code Angular, so I went out and started reading the website on how to code Angular and got my first little Hello World app to run. And then I said, well, how do I secure this? So I started Googling securing Angular applications. Horrible, 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 horrible things came back. It was wrong. I didn't know much about Angular, but I knew what they were telling me to do on the server, and it was just wrong. So that's kind of how I got into doing this. So I am few basic concepts of my design. This was sort of my design of how I approach this is, one, I am not a great Angular developer. I am marginal at best. I can do some pretty decent things, but that's not uncommon. A lot of people that will use your web services are marginal at best. They will just have gotten the hello world to work, and they'll be coding away on your website. So I do know security pretty well, so I was a good candidate for going through this process. And also, I'll put up a design concept here. If you can trust what I'm saying, just on my experience, but verify me, go get other people's opinions on this. If you're designing highly secure things, get lots of opinions. I also wanted this to be very simple, be very secure, and I wanted to make it really hard to break rules. So let's talk about the application I'm going to be using as my demo today. Really simple application. All it did was let a user register for a conference. So the concept, the structure was really pretty simple, and I'll just go through kind of quickly how it worked. I have an Angular application that loaded up. It had a really simple little web form. It then sent a request off to a RESTful web service that came back, and that's over here on the left-hand side, that was basically what options could the person sign up for. Somewhere my mouse will show up here in a second. So I could put down what are all the options that I can sign up for, and it was an array of those. And then it was the basic information like what's your name, what's your phone number, what's your address. It was defaulting it for the user, so they didn't have to retype everything. And they've got the ability to click the little add more users button, and it could add more people they wanted to register. The structure, pretty traditional Angular application. Had my basic HTML page. I then have my apps.js, which was had all my routing information. Had my controller, which had all of my sort of controller logic, dealt with click events, all those kinds of fun things. And then I had some services. And I'll show a bit of those in just a second. That's boring code, just a router. So one of the things I noticed, and this is one of the first things I noticed from a coding perspective, and I'll get into this in just a second. There were a couple of ways to call web services, and some of them I like and some of them I didn't like, and I'm sure a lot of people in this room can tell me why other ways are better, and that's cool too. One thing I noticed when I was calling RESTful services, I had basically the way I designed them, and we'll talk about the design considerations in a second. I wanted to have the ability to say there's a pass and a fail state. So the classic, like Node.js where you've got, you give a call back and it says pass, you've got an error or a data that comes back to you. I like that. I like that style of coding because if the user asked me to do something, I wanted to be able to either say, yep, I did it, or no, and why. So for example, they could have passed me bad data. I wanted to be able to throw an error for that. Maybe they weren't logged in. I wanted to be able to tell them that. I wanted to be able to give them information back about either what you asked me to do worked or it failed, and if it failed, why did it fail, and how could they correct that issue. I found coding with the HTTP object, which is in the next page, using the HTTP object much easier than some of the other methods that were available in Angular, just because they do expose those low-level different. You can either get a 200 OK back, which is a standard return, or the fact that you could send like a 500 or some sort of other status code back and deal with that as an error. I like that. It was easy. It was very easy for me to understand. When I asked some other people how to deal with it, they talked about lots of other techniques, and honestly, for me, this was just the simplest way. I'll show you another reason that I like this. So one of them was how to authenticate the user. So I was going to be calling a series of RESTful web services. I wanted to be able to use very standard RESTful web services, so get, put, post, delete, all the standards. I wanted to be able to send credentials over SSL on a post, so very kind of boring sort of mechanism for calling it. I wanted to be able to use standard HTTP response codes. A couple reasons I wanted to do this. One is it's easy, it's standard, all browsers, all servers support it. Also from a design perspective, there's been an interesting change over the years, and it's kind of been an interesting thing for me as having sort of been an AppSec for so many years. Back in the early 2000s-ish or so, when application security first became a thing, there was about a 5-year period there where security people were running around saying, oh, don't turn on the error messages. You should send only 200 OKs back to the user. Because if you send anything else, you're telling them about their web server. I don't know if you've been around some security people. A lot of people would change, for example, the server header that was sent back to the client. So if they were ASP, it would say I'm, Billy Bob or whatever. All of those things failed, just across the board. Okay. The fact is, if you're even the remotely decent hacker or pen tester, you can figure out about that fast what's running on the backend server. Just there are tools that do it. It's easy. So that sort of thought process that was prevalent in the 2000 to 2010 is really going away now. Especially in the term of RESTful web services, what people are saying is, look, just deal with all of your errors, but use your native status codes. So everything becomes very standard again, which was really nice as a developer. But we used to have to do all this voodoo stuff to try to figure out what was going on the server. Now, really, people have headed back as a design consideration. And this is not just in Angular. This is kind of like across the industry that I've seen. We're going back to using native status codes. So when I'm doing RESTful web services, I like the native status codes. One, it just makes it easy. It's obvious. It's simple. You still follow all the good rules of not returning really verbose error messages. But for example, if somebody sends you data and you want to return, if they're not logged in, and it's okay for me to send a 403 forbidden and say, I know who you are, but you can't do what you're asking to do. There's a status code for that. So if somebody tries to do something they're not supposed to do, there's a status code for that. If they ask to do something and you don't know who they are yet, then there's a status code for that. It's called a 401 unauthenticated. You can return that in a web call. And then it's very standard across whatever development and front end somebody's using to call your RESTful web service. It's going to be a very industry standard kind of thing. It's easy to understand. Again, the goal is to make it easy for your developers to consume your service and be secure. It should be both. So that was one of the concepts that I definitely wanted to do. One of the first challenges I ran into with Angular applications was session state. And some of you may have run into this. If you're doing mobile application development, this may have bitten you a few times in the past. So let's talk about how session state works in a traditional application and what's different when you go to Angular or mobile application development. So using standard session state, what happens is the user hits your website, they send a request off to the website, they have a session token, probably like an ASP.NET session token or a JSession ID or one of those. As soon as that website gets the request, it takes the session token, goes and looks it up in this little hash table of sessions, and it says, oh, welcome back. You've got X number of minutes more time on this server before I log you out. And every time they send a request, that timer gets reset. Reset, reset, reset. So it's kind of pushing it along. An average is 15 minutes. Some people set it to ridiculously high numbers of days. Don't do that, by the way. If your session times out are set really high, stop that. All kinds of performance issues if you do that. So anyway, side note. So as these requests come in, session time gets reset, session time gets reset, session time gets reset, everybody's fat and happy. Now then, if you're looking at an Angular application or a mobile application or something that sends a request off to the web server, it then goes and grabs some data, so you're kind of your traditional, heavy client-side JavaScript app. You load the HTML page, you load up all the JSON data from a RESTful web service, then the user sits there and does something. So in my example, I had my little online application where you could fill out a registration form. It was asking for a lot of information, and we had people that were registering like 10 and 15 users. So it was add user, put in Bob's name, go over to Mary's desk. Mary, what's your phone number? Mary's phone number, come back. And they would sit here and work on this thing for 20, 30 minutes. Meanwhile, whenever they posted the data back to the server to say, hey, here, I want to register this group of people now, it's just a nice little JSON object. The timeout that the native session management system was using had timed out. So they do all this work, get it all nice and packaged up, And they posted that data back, and I would say, logged out, go log in. And we had really unhappy users. So native sessioning didn't work. I had one of two choices. Option one was increase the session timeout on the server. The problem with that is you get into all kinds of server performance issues. You're keeping too much junk on your server, and that's just not efficient. You want to be as efficient as possible on your server. The other option was to roll my own session token. So, and I had a big old fat bug in my app. So I was like, okay, well, how do we fix this? What's a secure way to do this? So I jumped firmly into an area I hate to jump into. That was creating a session token that was secure and would work and would last a long time. I hate rolling my own session tokens. Again, under the philosophy of limit the number of people that have to make security decisions, I didn't want to do this, but I had no choice. So what I had to do was create a session token that lasted longer than 15 minutes. So basically that meant creating a session token, sending it to the user. I chose the route of sending in a cookie. Again, it's really boring and easy to do this. I talked to other people that were doing this. I've got a couple of companies I was working with, and what they were doing was they were sending custom headers back in the HTTP, or they were sending something back in the HTTP response. The problem is, in my opinion, in that is that you then had junior developers that had to consume that. So they had to know how to deal with HTTP headers and pull them out and where to put them back in, and it got sloppy. Cookies always work. They're boring, they always work. If you want to track it some other way, you can, but cookies to me were very simple, and all I did was set a really nice long session timeout on this guy. So two things that you've got to keep in mind in this case, and this is just something I think as Angular developers you'll have to deal with. One is your cookies need to be unique, and the second thing is they have to be cryptographically random. Those are two distinctly separate things. So I used a GUID for my uniqueness. So to get a unique session token, I used a GUID. GUIDs, though, are not cryptographically random. They don't repeat, but they are predictable. And they're actually really easy to predict if you are into cryptography. So GUIDs are good for uniqueness. They stink for randomness. So then I had to give it a cryptographically random string to make sure that no one could guess what my session token was, so nobody could kind of brute force it. I chose to use a function of the backend was .NET. It was this RNG crypto service provider. It's a fairly standard service provider for cryptography. Again, I would suggest use a standard library. Don't roll your own cryptography. You'll get burned if you do. Somebody will crack it. They just will. I know people that do it every day. I then set a nice long timeout. So here was the risk with a long timeout. If you have a long timeout, the probability that somebody steals someone else's session token and does something bad with it increases exponentially. 15 minutes isn't that long. 2 days, 5 days, 10 days, 6 months, that's a long session token. The opportunity, your profile of when that can happen, goes up dramatically. However, in this case, I wanted to have it where this was a conferencing system, so people kind of just come back to it randomly throughout a conference. So I wanted to have a nice long timeout, but I didn't want to have any security issues. So I'll show you how I dealt with that in just a second. Also on the cookie, make sure you set your cookie to secure, just so it always goes over SSL. That's typically a server setting, by the way, so not a whole lot you have to code there. It's kind of a server thing. So we set the cookie. To deal with a long session timeouts, I took the approach that Amazon uses, and I brought up Amazon as an example just because I think they do a really nice job of it. I know a bunch of the folks there, and that they really focus on this a lot. So on Amazon, if you've used it, like if you're a Prime member, when you log in, it keeps you logged in for a long period of time. But then when you go to buy something, so it knows who I am. Actually, it knows who my wife is in this case. It's her account, so she's Susan. It knows who Susan is, but then when she goes to buy something, it goes ahead and lets her add stuff to the shopping cart. So we haven't done anything really secure yet. We've done kind of like secure stuff, but nothing really big. But before we do something that really has a security impact, they make you re-authenticate. So you're still logged in, they're not changing session state, they're just saying, okay, you're about to do something really important, log in again. Give me your password again. Really, really good approach. Very good approach. What it allows you to do is have long session timeouts. So anything that's moderately secure, like, I log in and I'm Susan and I don't want somebody filling up my shopping cart. That's okay to have long session timeouts, but when you're going to do something, if you're going to do that, when you're going to do something really important, stop, make somebody authenticate again. And people are kind of used to it anymore, okay? So that actually helps quite a bit. Another thing that you should do, and I didn't have time to really put this in the slides, which I apologize for. Something that actually works really, really well, and just as a side note, if you've ever used any of the systems where when you go to log into a system and you're on a new computer, it texts you a message, or you change your password and it texts you and says, enter the code we just texted you, and you put in the code, that two-factor authentication, consistently when I'm talking to penetration testers, the thing they break the most is password changes and authentication changes. Anytime somebody's changing a password, people just mess that up. Even if you do it perfectly, people have passwords in their Gmail accounts like dog or password, or there's all these, people use weak passwords. You completely avoid a whole category of problems, and quite frankly, the most common problems, by sort of removing that human element to the extent possible. So the whole thing of sending a text to somebody, you want to change your password, no problems. I just sent you send them a text, they get a code, they type the code in the browser, and they go on. That'll remove, a huge percentage of the application security vulnerabilities that people actually get exploited with. There's a couple of systems out there that you can call web service APIs to send text. They're cheap. It's like, I was doing one last week, and it was, I think, 0.6 cents per text. So the cost to do that versus the cost of trying to go reset passwords of all your users is massively better. So those systems actually work really well. They're simple, they're cheap, they work great. So from a password reset perspective, I really suggest looking into those. And you can roll your own. It's simple. You send a random 5-digit code off to your users and say, give me this code back. So let's jump back in. So let's look at another type of tampering, and this is actually really common. It's just data tampering. This has been around forever. When we first founded SPY, we did SPY Dynamics, we did a penetration test for a company here in town, and we found that they were using a hidden parameter, so really old school, right? They were using a hidden parameter, and it had discount. So as you were shopping, there was this little thing called discount percentage, and we thought, that's kind of cool. So we just changed the discount percentage from 0 to 99. And all of a sudden, our prices were like 99% cheaper, and we thought, well, that's kind of cool, but this will never work. Nobody's going to ship this thing. So we bought like 10 shirts, some books, all kinds of junk, and we're just shopping, and really we're just testing the website. So at the end, we were like, what the heck, let's see what happens. So we checked out, and they FedExed it to us. Well, their FedEx billing was based on the price, so we had this huge box, like $5 in FedEx. It's awesome. So we got to do the penetration test report to the customer, and it was like, here's your report, and it was a PDF, and then we set a box down and gave them all t-shirts. So that's like old school, like, oh, nobody would ever make that mistake again. Yeah, they will. So let's look at how that works in the modern world. So very simple. JSON, so data tampering. So the client, so here's the basic concept. Client sends data, or the server sends data to the client. Client manipulates it. For example, in my registration system, I was putting in, what options did you want to choose, how many people are coming, all that kind of good garbage. And then the client modifies the object and sends it back to the server. The problem in that is that there's some of the data that you wanted people to change and some of them that you didn't want them to change. And it's really, really easy to be really sloppy on the server side. So let me show you how that worked in my code. So I literally wrote this application. So I've been doing this for 14 years. So I wrote this. I'm not proud of it. Wrote the code. So in this case, the client received a big chunk of JavaScript, and it was just a big JSON object that had all of the options, and it had the price and the quantity of things they wanted. And it was kind of setting up the basic data that I wanted to render on the screen. And then what I did is, it would send an HTTP request, which was a GET, and that, as you can see, it's got like options and the descriptions of the options and the price and the totals and all that kind of fun stuff. Client manipulates it, and then the client would then, when they were through registering, would post the object back. So it was just a simple post, actually it was a put. They would do a put back to the RESTful web service, and it had some of the data that I wanted them to play with. For example, they could change their name, they could change their phone number, they could do all those kinds of things. But price was not necessarily something I wanted them to change. But I wasn't, because it was in a text box, I was just displaying it. I didn't really think like, okay, is somebody going to do that? The problem was, so I actually did this. I coded this site, and I was taking the data out. I took the JSON straight out off of the put, and then stuck it into a Mongo database, which is really easy, by the way. I like Mongo. You can just take JSON objects and go, save that. And it worked great. Coded it, I'm testing it, and I thought, you're an idiot, don't do that. So literally, I went in there and said, okay, let's see if I can change the price, and I could. I changed my own price, and it hacked my own system. been doing this forever. The problem was I wasn't thinking through what data came from the client, what data was supposed to come from the server. So what I actually had to do was take the JSON object, deserialize it into an object, go get the original thing that I had rendered that JSON object from out of the database, which was basically a record that represented a conference, and then go, okay, what was the original price this guy was supposed to get? Oh, it was $300. Is it still $300? Yep, okay, we're good. And I had to go through and look and see, did somebody manipulate this data? Did they change it? And did it work? So had I not done that little piece of code, you could have really easily changed the data on the fly on the way in. Now I thought, okay, nobody else would actually do this, right? So I called some of my friends that do lots of pen testing, and I said, hey, tell me if you see this. And they were like, oh gosh, yes. One of them that we saw was a security company. They were taking logs off of a system that they knew could have been hacked and sticking it into a database, and they were not data validating it on the way in because it was the same kind of situation where they thought, well, it's in JSON format, it must be okay. They hadn't thought through what if the hacker owns the system that the JSON came from. We stick it in the database. So validate all of the data that comes back from the server. I'm going to show you a couple ways to do that. One of the ways that I approach this, and I think this is something that is a good practice in general, is to very, very, very clearly document the data that you render back in RESTful web services. What I mean by that is, and this is a little spreadsheet that I came up with that I did it with, which basically said, here's all the data on the left-hand side, and based on a role, what can you do? So can you search on it? Can you view it? Can you edit it? And I went through and just kind of documented what role should be able to do what to what data. Totally forgetting what the client was going to render that as. I just said, just the objects I'm going to send back and forth to these RESTful web services, what should the client be able to touch and what should they not be able to touch? And then I tested it. And it turns out that I'd messed up a few places. So that act of just testing, and it's simple, you create a RESTful test, create your little test harness, and just start manipulating data. Okay, I'm logged in as a user, what can I see, what can I change? Was that right? Did I verify it in the database? So check where the RESTful web service is getting posted into your backend website, and is it following your rules? This will also help you, by the way, in an audit. If you have a pen test, and you give a pen tester this and say, here's what the rules are supposed to be. It's incredibly helpful to them. It goes from them just randomly hacking your website to them actually giving you valuable information saying, did you follow your rules you think you followed? It really is very helpful. And you can get a lot better information back as a developer to say, did I meet my objectives versus just, I hacked you. Okay. So how do people hack data in the middle? Let's talk about some of the methods for doing that. And you can do this testing on your own. There are a number of tools out there. One of them that I really like is called Burp. Weird name. Have no idea where the name came from. It's called Burp or Burp Suite. Basically what Burp does, and the product I wrote long ago was bought by HP, but it's a commercial product. Still very good, just not free. Burp Suite, there's a free version of it. And basically what it does is it lets you act as a man in the middle. Now keep in mind, some people will say, well, I'm SSL, so this doesn't apply to me. So let's go kind of back to the basics. If somebody's attacking your web application, they're doing it on their machine. I'm the hacker, I'm sitting on my computer attacking your website. So all rules of SSL terminate at my network card, basically. So I can terminate my own SSL in the localhost proxy. Can I show you how that works real quick? It's kind of cool. If you've never used a localhost proxy, they are incredibly helpful tools. So basically what happens is, I go into, and this is Burp, and I'll make these slides available online, or if you want to come and ask me afterwards, you're welcome to. This is called Burp. Basically, all I do is go in, and I tell it to listen on a local host address, so 127.0.0.1. I tell it what port I would like for it to listen on. It then goes into basically sitting there and listening to whatever comes in. I then go into my browser and go to the handy-dandy options screen, go to network, go to settings, tell it to use a localhost proxy. If you're developing, what's nice, I like using Firefox. It's nice you can tell it to not bypass anything, in which case it'll actually route, it'll send the request from your browser to Burp, let you see the request, and then send it back to your localhost web server. So it's kind of handy. We set that up, and then any traffic that we browse to, so anytime we're just bebopping around. Yeah, sure. I haven't played with that one that much. To CNN. So as I'm browsing around, it's basically going to show me every single request that my browser sends. Now, this is not unlike debug mode. In browsers, obviously, you can put them in a debug mode. What I like about this, though, is it's totally independent of the browser, okay? So I can see, for example, the raw HTTP request. I can see the raw response. I can even put it into an blocking mode where it'll stop the request, let you play around with it, and then send that to the server. So I can change anything I want on the fly, even if it's SSL. It basically terminates the SSL and then re-encrypts it on the way out the door. Really handy, but it does take all of the browser away from it. It sort of strips the browser out of your world, which from a testing perspective is nice. It shows you what's really going on the wire. I know there was another gentleman that just gave a talk on debugging, and he had talked about using things like Wireshark, which I like Wireshark, but it's, in my opinion, it's a little bit too low level. It's like looking at the packet traffic on your wire. Something like Burp is really nice, just if you're doing web stuff, because you can trap it. Also, if you're doing mobile development, really handy tool, because what you can do is run your mobile app, turn off your data connector, like Verizon or whoever you use for your phone, turn on Wi-Fi, and then use your app and run it. You can run it through a local host proxy, and you can sit there and watch the traffic that goes back and forth from a mobile app back to the back end. So a really nice way of testing. A lot of pen testers, that's sort of a standard technique that they use. So again, that's called Burp Suite. It's free. You can download it. Really, really handy tool. But basically, again, it's just going to sit there as a man in the middle. Talk about a few other things. API abuse. And I just keep checking the watch just because this is the first time I've given this talk, so I have no idea how fast we're going to go, and I hate running out of time. So, and I want to leave some time at the middle end to talk about for Q&A. So let's talk about API abuse real quick. Fun subject. API abuse has been around forever. Who's seen the movie War Games? Remember? Would you like to play a game? Probably seen that. Global thermonuclear war. We'll use that as an example. So that's the server from it, by the way. Now, I use that server for a reason. People go, that's old. There are servers running in Atlanta today that do really important things like tell you which airplanes fly, older than this. So there's code that's older than me. So like the people that wrote it are dead, probably. So it's old code. So I use the old server because it's, well, it's funny, but also just to make a point that there's some really old boxes back there, and here's a fairly common type of attack that occurs, and I've seen this repeatedly in the real world. What happens is you've got an old server on the back end, some old mainframe, some old banking system, whatever it is, was designed way before the web, and the way that people webify that is they put a web server, like a RESTful, something that's got a web services API in the middle. It's got all the hooks to get back to the back end. And the expectation is that a user comes in and asks, questions like, will there be cake? And the little middle where a server goes to the mainframe and says, well, is there going to be cake? Ask the question, and the server responds, yes, there'll be cake. If you've played Portal, you know who GLaDOS is. And then it gives the client, says, yes, there'll be cake. So it's a proxy, right? It's basically just kind of sitting in the middle, passing stuff back and forth. That's its life. Then comes along somebody who wishes to misuse your system and ask questions you didn't expect. So if you remember the movie War Games, he was asked the question, this little screen pops up and says, do you want to play a game? And he chooses global thermonuclear warfare. So this is a case, and what happens here is with API abuse is somebody sends a request to that middleware web server that's malicious. The middleware web server is kind of supposed to be the traffic cop. It's supposed to look at the request and ask all those nice questions like, are you authenticated? Are you authorized? Are you coming from a machine I know about? Are you asking for something you're supposed to do? Like, are you asking about cake? That frequently doesn't happen. And I've seen this happen over again where somebody simply creates basically a proxy that goes, you asked a question, let's throw it to the backend server. And it just proxies the request. So no matter what you ask, it simply passes it along. The problem is the code running on that backend server is really old. It didn't think about malicious people because it was in a nice little protected data center with no external users when it was written. So it's just written before this kind of stuff happened, and it does something really bad. So it was global thermonuclear war in the movie, by the way. So anyway, that does happen. We did a pen test, or actually we did some consulting with a company here in town. I won't tell you who they are because it'd be embarrassing. And they literally had this running on one of their networks. They had a really significant transportation system that you literally could have stopped dead by sending a couple of requests to their web service because they had an old mainframe and there were commands in there like stop, but I don't want to give you too much information. You could stop some really big things from moving around. Just a lot of people would have been really upset. Things like this happen all the time. There's a story of actually it was down in Houston when this happened. There was a little pump for fuel tanks. It pumped gasoline. You guys remember back in the hurricane, when the hurricane hit 3 or 4 years ago, and we ran out of gasoline in Atlanta? If you were ever wondering, so like, we just ran out of gas. Why everybody's like, but there's no hurricane. We have no gasoline. Here's what happened. There was a pump that pumped gasoline from Houston to Atlanta. It was a series of pumps, actually, but this was the first in the food chain. When the hurricane hit Atlanta, somebody sent a command to the pump to say, stop pumping, because the hurricane was there and bad things happened. They never sent the command to the pump to say, start pumping again. So no gasoline was pumped. No gasoline was pumped, so we had no gasoline in our pumps here in Atlanta, and we all had to pay lots of money, and we ran out of gas. That's why. What they did, then did a pen test to see, well, could somebody have done this from the outside world? And it turns out they could, because somebody had a web API interface just like this. You could have sent a command to basically every pump in Texas to say, stop running, and they would have stopped, and all of our cars would have run out of gas. So this does happen. Just keep in mind, if you're writing this kind of code, especially this middleware code, this API abuse kind of code, it happens. Be very careful. Make sure, verify your assumptions before you write code. So let's go back to our original list, and I'm going to leave room for questions at the end of this. So we talked about the 8 kingdoms of security, and I wanted to kind of relate those back to how they affect Angular, RESTful web service type applications. So input validation, this has always been a problem. Things like SQL injection, cross-site scripting, buffer overflows, all of those are related to input validation. So the old rules still apply. You still have to do good input validation. If you're dealing with JSON data, I've seen all these articles, and they terrify me, where people are saying, what's really cool about JavaScript is we have the same language on the client and the server, so we really you almost don't even have to think about where you're writing code for, which as a developer I like, as a security person horrifies me. Think about where your code runs. Like, think about the assumptions, think about where that data comes from and it goes to, because it could be coming from somewhere that you don't trust. So input validation is a big deal. We talked about API abuse in our little global thermonuclear warfare example. Security features. We talked about this when we were talking about things like authentication, authorization. We talked about texting people a code to get their new password. When you're dealing with things like session timeouts, how you deal with session in applications that aren't traditional and don't have these nice little short timeouts that you can deal with, keeping in mind that if you have a long timeout, that's okay, but you need to re-verify people before they do particularly obscure things, like write checks or transfer money, big things. Time and state, we really don't, that's really related to multi-threaded environments, kind of beyond the scope of this. Error messages, this is a big one as a security person. I can tell you, having hacked a lot of websites over the years, most of hacking, like 99% of it, is just information gathering. It's learning how your website works and just testing it. It's playing with your website. That's how almost every hack that ever happens because somebody they sit there and very persistently play with your website, their application. They try to break stuff. They look for assumptions that you've made. And a lot of times people are more successful at hacking because the error messages that come back are verbose. So, trap your errors, don't return verbose error messages. I mentioned that it was okay to do things like send back a 500 error, but it's not okay to send back a 500 error with a big, huge Java stack trace. It is okay to send back a 500 error and say, hey, you sent me garbage data and I'm not going to deal with that. Okay? That's different than a big, fat, not trapped error. Just let the server deal with it error. So deal with your own errors. Always do error trapping. Always put things in try except blocks. Don't let your errors roll back up. A lot of developers will rely on their operations team to turn off verbose error messages. Don't do that. Seriously, don't do it. The reason for that is that somebody, and this happens all the time, a big bank I was working with had this happen where their application stopped working at about 2 in the morning, so somebody ran in and did something to fix it, and in the process of fixing it, they turned on error messages, because error messages help you fix things. As soon as it started working, the guys in the data center said, don't touch it. Just don't touch it. Just leave. Go away. Because it was running, and there was great joy and happiness in the room. On Monday morning when the security team came in, they hit the website, did 2 things, and a big old error message came up, and they about had a stroke because it was telling them like all the internals of the banking system. So again, don't trust your operations people. They're good people, but everybody makes mistakes. Deal with their own errors. Don't put big verbose error messages on the screen. Hackers love that. One of the big ones too is the lack of strong boundaries. I see this happening a lot and talking to some of the folks that do mobile app testing. This is one that just shows up just all the time. Because you can write really high quality code or really complicated code in JavaScript now, developers will make the mistake of putting complicated business logic in the client, which is not horrible as long as you're not giving away any secrets. There are no secrets in the client. If you think there's any secrets in the client, you're wrong. There are none. There are no secrets. I'll give you a great example of that in just a second, by the way. Anything you let the client do, any business logic on the client side needs to be re-verified on the server side. So don't give away secrets. Don't ever send business logic to a client that you don't mind the customer in detail and with a microscope looking at, and then re-verify it on the server. Never, 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 never trust the client because they can change anything. Give you an example of that. If you remember when DVDs came out, they were very proud of the fact that they were encrypted. Ooh, nobody can hack our DVDs. Within about 2 days of DSS being shipped, it had been hacked. You can now go to Black Hat and get a t-shirt that has the decryption algorithm for DSS, which is how DVDs are encrypted, in the form of a haiku on a t-shirt. There are no secrets, okay, on the client, ever. That was one of my favorites. I love that t-shirt. The last one is environment. Really, that's beyond the scope of this. That's really hardening the web server, which is kind of beyond the scope of this talk. General good practices, just sort of my summary slide on this of best practices for dealing with things. One, have a good architecture, especially as it relates to that point between your server and your client. So there's where the RESTful web services are, document that. You may not document anything else. We all should, but it's hard and it takes time. Document the interfaces. That's where the hackers are going to come after you. Is that's kind of the inflection point where the hackers are going to go for first. They're going to go after your web services. They're going to dissect your code in your Angular application. They're going to read it all, and then they're going to go dissect you on the server side. So that point where they talk, all those communication points, document it and understand exactly what the rules should be. Keep it simple. Keep it up to date. Have it there for a review. Also test your applications. There's multiple methods of testing applications. There's things like static source code analysis, which looks at the source code for common errors. There's dynamic testing, which is kind of it's an automated penetration testing, what WebInspect does. There's penetration testers. If you're doing something highly secure, get a good pen tester. I would suggest, I can give you all kinds of advice on pen testers, but make sure they know what they're doing. Like, the pen tester that you're hiring should be published. They should speak at conferences. They should be good. There are some people out there that are just really not very good at it. There are others that scare me a lot. They can break anything. So there are good ones out there. I'm not one. I can hack stuff, but these guys are way better than me. Also mention, if you ever talk about testing, security testing, and your managers say, oh, that's not that important, I always tell people, keep in mind, you will be tested. You might want to be the one that does it first. Because when the hacker does it, they're not as nice as you are. So, you will be tested if your management says, oh, we don't need to do that because nobody would do some bad thing to us. Yeah, they would. Also, last thing, as a developer, I strongly suggest integrate your testing of your applications into your SDLC, especially if you're agile. So if you're doing agile development, you've got your scrums where you develop, in a nice iterative process. Do your security testing as part of that iterative process. The reason for that, and what the mistake a lot of people make, is they wait until the very end of the agile development lifecycle to test. The problem with that is that if you're doing agile, when you get to that last cycle, you kind of think you're going to ship. Like, you're way out there somewhere. And there'll be this thing called the hardening phase in agile processes. The hardening phase is for the server. It's, does our application run when the server is hardened? It is not, is my code secure? If you're testing your code at the last cycle, you're probably going to get burned someday. Because if we find an architectural issue late in the development cycle, you've got to go back and touch code that you thought was done 3-6 months ago. So make that testing part of the whole process. It's much less painful to do it that way. So you integrate it, so that every Scrum cycle you're doing some testing, you find issues, that's great, you fix them, you go on with life. You deal with them just like every other bug. So especially if you're agile, test early. If you're waterfall, still a good idea to test early, but agile, it'll burn you much worse if you test early or test late. I've got about 10 minutes, which actually is perfect because I wanted to leave about 10 minutes for Q&A. That's, if you scan that barcode, it'll just take you to my website. Any questions about security in general, Angular specifically, mobile apps? Kind of open up the floor. Yes? Mm-hmm. Yeah, so so you're talking about the case where I've got an application, I've got my web application running on server A, and I've got a web service sitting on service B, and then what are the rules around that? Right. So the whole cross-domain the cross-domain issues primarily came up because of cross-site scripting and cross-site scripting was the biggie. For that, it was to try to protect the client. On the server side, really what you've got to, so from the server side of it, you never, ever, ever trust that somebody's coming to you from the same domain. You just assume that they're coming from anywhere because they can lie prolifically about that. So I can tell you I'm coming from anywhere. I can give you any refer header. I've seen people do things like rely on a refer header, which they can change those in 2 seconds. So it does relate, it really relates more to kind of the classic issues like cross-site scripting and trust of domains. It's really more protecting your clients. The challenge I'm seeing now is that so many things are cross-domain, where you've got a web service and you're calling it from multiple locations. That is a challenge. So, question? More questions? I appreciate you guys coming. I'll hang out for a few minutes. I think I can hang up around up here for about 9 minutes, and then the next speaker will be here. Thank you very much for coming. I really appreciate it. Y'all have a great day.